Show that 12 raised to n cannot end with digits 0 or 5 for any natural number n. So, first of all, 12 can be expressed as the product of prime. We know that by fundamental theorem of arithmetic, any number can be expressed as product of prime. So, similarly, 12 can be written as 4 multiplied with 3. 4 can be again reduced into 2 square multiplied with 3. So, 12 raised to n that can be expressed as 2 square multiplied with 3 the whole raised to n. Now, you can see that to n with a digit 0, there should be a 5, right? Because for some n, let us assume for n equal to 1, we have a 2 here. So, 2 multiplied with 5, we have 10. So, the last digit must be 0. Similarly, here if there is a 5, 5 multiplied with 3, we have 15. So, the last digit must be equal to 5. So, here for any n, we will not have such a possibility because 5 does not exist in 12. So, we can conclude that it is impossible to have digit 0 or 5 for some power of n. Now, let us go for next one. Two numbers are in the ratio 2:3 and their LCM is 180. What is the HCF of these numbers? Since it is given that two numbers are in the ratio 2:3, we can say that let the numbers be that is equal to 2x and 3x. Now, we know that to calculate the LCM of 2 square multiplied with 5 multiplied with 3 and 2 square multiplied with 5 multiplied with 7, the LCM of these two terms, we know that this is equal to 2 square multiplied with 5 multiplied with 3 multiplied with 7. This is the LCM of these two numbers. We know that. By similar fashion, what is the LCM of 2x and 3x? There is an x. You can choose 2 square multiplied with 5 as an x. So, there is an x over here. So, we know that number and the remaining portion is 2 and 3. Similarly, the LCM of 2x and 3x, that will be equal to 2 multiplied with x multiplied with 3. So, we know that the LCM is equal to 6x. But it is given that the LCM of these two numbers, that is 180. So, we can find 6x is equal to 180, 6x is equal to 180 in which x is equal to 30. So, now we know the value of x is equal to 30. Since the value of x is equal to 30, we can calculate the numbers. What are the numbers? The numbers will be 2 multiplied with 30, 60 and 3 multiplied with 30, 90. Now, we know a relation connecting LCM, HCF and product of two numbers. Product of two numbers, that is equal to HCF multiplied with LCM. So, that is equal to LCM multiplied with HCF. On simplification, we have 6 multiplied with 30 multiplied with 30, which is equal to 180 into HCF. On simplification, we can cancel out and the HCF, that will be equal to 30. Next one, find the greatest number which divides 85 and 72, leaving remainder 1 and 2 respectively. There is a number, let me take that number as x. If we divide x by 85, we have remainder 1, and if we divide the same x by 72, we have remainder 2. Okay. So, that means if we subtract 1 from 85, that particular x divides 85. Similarly, if we subtract 2 from 72, that particular x divides 72. So, the numbers are basically 84 and 70. They are the numbers. Okay. So, we know that 84 can be written as 2 square multiplied with 3 multiplied with 7. Similarly, 70 can be written as 2 multiplied with 5 multiplied with 7. So, we need to find the greatest number that divides both 84 and 70. So, they must be here. You can see that that is the greatest number. So, that is the highest common factor. So, what is the highest common factor? Indirectly, they are asking to find the highest common factor of these two numbers. So, what are the greatest number that is going to divide these two numbers? You know that here we have a 2 common, here also there is a 2. Here we have a 7 common, here also we have 7. So, the HCF of these two numbers, that is equal to 2 multiplied with 7, which is equal to 14. Next one. In a teacher's workshop, the number of teachers teaching French, Hindi and English are 42, 48, 80 and 144 respectively. Find the minimum number of rooms required if in each room the same number of teachers are selected, all of them are of the same subject. So, this is usually happening in our schools too. We have certain teachers who teach us French, Hindi or English. So, they will be sitting in a single room or they will be having a department wise room. So, similarly, we need to find. So first of all, the number of teachers who teaches French, that is equal to 48, and we need to find the, basically we need to calculate the HCF. So we have 48, 80 and 144. So 48, that can be represented as 2 raised to 4 multiplied with 3. Similarly, 80 can be written as 2 raised to 4 multiplied with 5. Similarly, 144 can be written as 2 raised to 4 multiplied with 3 square. From this, we can conclude that the HCF of this number, HCF of 2 raised to 4 into 3, comma 2 raised to 4 into 5, comma 2 raised to 4 into 3 square. So here there is a 2 raised to 4 common, here also 2 raised to 4 common, here also 2 raised to 4. So the HCF of these these numbers, that is equal to raised to 4, which is equal to 16. So the HCF, that is 60. Now there are teachers who teaches, there must be 16 teachers in same room. Okay. So number of rooms required for a French teacher, that can be equal to, there are 48 teachers. So 48 divided by 16, which is equal to 3. For a Hindi teacher, we have 80 Hindi teachers. So 80 divided by 16, which is equal to 5. Similarly, for an English teacher, we have 144 divided by 16, which is equal to 9. So there are 9 teachers who are sitting in a room who teaches English. Also there are Hindi teachers, 5 Hindi teachers and 3 rooms for our French teachers. So the total minimum number of rooms, that will be equal to 3 plus 5 plus 9, which is equal to 17.